ask you, and this is something from regular algebra, if I asked you to simplify this, okay, as simple as it looks, my guess is the majority of you would get it wrong. And having pointed that out, what do you think the answer would be if you take the square root of x squared? Okay, in your algebra classes, you guys all just solve this as x, right? But it's not x. It's the absolute value of x. Okay, and so in this class, this year, you're going to need to be able to distinguish when you need absolute values and when you don't. Okay, so you guys ready to take a look at some rules? Okay. So let's kind of go through some different examples of this. All right. Anytime you're simplifying radicals, and I'll talk through the steps of this in a little more detail when we come back from break, but you'll hear my terminology. What you're really doing is you're looking for groups of this index here to pull out. So again, what we saw was the nth root of a to the n is equal to, again, a or absolute value of a, depending on some rules. Okay, but we want to look at pulling those factors out. So when you simplify the square root of x cubed, again, you may already know how to do it, but really what you're looking to do is you're looking to remove the square root of x squared in groups. So groups of x squared. So how many groups of 2 can you remove from 3? Just this one group. This one group of 2, because the index and power are the same, simplifies to just the base x. But when you remove that one group of 2, how many x's stayed inside the radical? You had 3 to start with, and you removed a group of 2. So now you have just 1 left. And so that's going to stay inside the radical itself. Okay, so when we look at this, okay, this is the simplifying part. So again, you've probably done some of this in your algebra class. What we're going to add to it this year is now you need to go in and see, do you need absolute values on this? Okay, and even though we set up some rules for it right here, okay, when you're actually evaluating for a variable, an unknown, you have to test those rules. Okay, so when we look at this original number here, the square root of x cubed, you need to check and see, can x be a negative number? Could we take a negative, cube it, which gives us an overall sign of what? Negative, and then take the square root of that. Can we take a square root of a negative value? No. So in this number, you know that x is restricted. It can't be a negative number. Is that restriction evident in this simplified form? Can you tell here that x can never be a negative number? Yeah, because it's restricted right here as well, right? Okay? Because of that, by looking at this problem, you know x can't be a negative number. So do you even need to consider the case where it's a negative out here? No. So you don't need absolute values for this. So even though it fits our rule, when we look beyond the rule at the different possibilities, we see that x cannot be a negative, so you don't even need to worry about it. Okay, let's say we move on to the square root of x to the 4th. Okay, so again, we're looking at groups of 2, whatever our index is. So how many groups of 2 x's can we pull out? 2. So we can pull out an x and an x, or an x squared. If we remove 2 groups of 2, how many x's will be left inside our radical? 0. So we have nothing left inside. This is all we have. And so we need to go back and see, is it possible that x could have been a negative number in here? You take a negative to an even power, 4. What's the overall sign going to be? Positive. Can you take the square root of a positive value? Yeah. Right, so when we look here, we do need to test. X can be a negative. If x is a negative, does this form guarantee that our answer is never a negative value? If you take a negative number and square it, does it become positive? Yeah. So it guarantees that, so you don't need any absolute values around this either. So you can just leave it as it is. The square takes care of the sign. So let's take a look at the next number in this order. Okay, so the square root of x to the 5th. If we look at how that is simplified. Okay, we look at our index, which is 2. How many groups of 2 can we remove from 5? two groups of 2, right? So that comes out as an x squared. When we remove two groups of 2, how many x's are left inside our radical? 1. Okay, so this would be our simplified form. Okay, once we have our simplified form, we now look to see, can we account for any negatives? Okay, can x be a negative number? If you took a negative to an odd power, your overall sign is going to be negative. Can you take a square root of a negative? No. So you know that x can't even be negative. Is that restriction shown in our simplified form? Yes. And so we know we don't even need to test. There's no reason to test for a negative x because it can't even be a negative x. All right, let's do one more example of this, kind of following this pattern. I want you to see if you can evaluate or simplify this radical. Square root of x to the 6th. Again, just take a moment. All right, so we're looking at an index of 2, so we're pulling out groups of 2. So how many groups of 2 can we remove from 6? 3, so that comes out as x to the 3rd, and it leaves how many inside the radical? None. So here's our simplified form. Now all we need to do is test for negatives. Could x be a negative number? If you take it to an even power, it becomes positive. The square root of a positive is positive, so it can be a negative. So what happens here in our simplified form? If x was a negative, are we guaranteed that this simplified form is never negative? No. So what do we need around the x? Absolute value. And so that would be your simplified form. You would need absolute values for that one. All right, so does everybody kind of see that process? It's a little bit new, and it will be, it'll take some getting used to, because again, you're going to be, you're going to fall into the habit of not worrying about it. But this is one of the things, it's a subtle thing, but it's one that you will be tested on. So the correct answer depends on you having the right absolute values if necessary. All right, let's take a look at some slightly more complex situations. Okay, and these are going to involve multiple variables. Okay, so when you simplify multiple variables, what's going to happen is you need to identify whether the x and y's are completely dependent on each other or independent of one another as far as whether they can be negative or not. So like in this example here, the square root of the product xy. Right? If x is a negative value, what do you know about y? It would also have to be negative. So x is negative dependent on y. So if one's negative, then they're both negative. If one's positive, then they both have to be positive. Otherwise, you can't take that even indexed root, or the square root in this case, of a negative. So the situation here, we need to check and see, or we can identify. There's no way to simplify this. You don't need any absolute values because x and y are either both negative or neither one's negative. Okay, let's say we take a look at the following situation. Okay, if I would ask you to simplify this expression. Okay, you go through, and the first step is to simplify it. So how many groups of 2 can you remove from the x's? 1. So the square root of x squared is just x. And how many groups of 2 can you remove from the y's? 1. So that comes out as a y. Are there going to be any x's and y's left inside the radical? No. So this is your simplified form. Now it's just a matter of figuring out, do we need absolute values or not? So let's look at x by itself. Okay, so is it possible for x to be a negative number in this original form? Yeah. Is it going to be dependent on y or completely independent from y? If x is a negative and you square it, it becomes a positive, so does it even matter what y is? No. So x is completely independent of y. So what we need to do is we need to kind of evaluate our simplified form. If x is a negative, regardless of what y is, are we guaranteed to get a non-negative value for this product? No. So what do we need around the x? Absolute values around the x. Okay, so now let's take a look at the y's. Can y even be a negative? If it were, you'd square it, it becomes a positive multiplied by anything, or this positive value here. So y, it is possible for y to be a negative. Is that going to be dependent on x or independent of x? Completely independent, right? So when we evaluate for y, we need to test and see. If y was a negative and we simplify this, would the simplified form guarantee us we will never have a negative value? No. So we need absolute values around the y as well. So the way that we'll do that, we'll just put it all around the entire product. And so that square root of x squared y squared actually simplifies into the absolute value of the product xy. All right. Yeah, PJ.
How do you know if it's independent or dependent on the variable?
Okay, let's take a look at the next example and see. All right, so the question was, how do you know if it's if a negative value is dependent or independent from the other variable? Okay, so let's take this example here: square root of x cubed, y cubed. Okay, so let's simplify first. So how many groups of 2 can we remove from the x's? 1. And how many x's will be left inside our radical when we do that? One group of 2 is 2. 2 removed from 3 leaves 1 inside. Okay, same thing with the y's, right? How many groups of 2 can we remove? 1. And how many y's will be left inside? 1. Okay, so here's our simplified form. And so this is as far as you guys have had to go in the past. Okay, but now let's take a look. Is it possible for x to be a negative? Well, if x is a negative and we cube it, we get a negative quantity. So the only way that that could exist underneath this radical is if the other factors have an overall value of negative. So that's dependent. There's a connection there. If x is negative, then y is also negative. Okay? If y is negative, then x is also negative. So they're dependent on one another. So when we go through and we test this to see do we need absolute values anywhere, if x is negative, then y is negative. So this is the only situation we need to take a look at. And if that's the case, is a negative times a negative underneath this radical going to be a non-negative? Yeah, so we don't need any absolute values here. What about here? A negative times a negative? It's going to be a positive. So do we need absolute values out here? No. And so we don't need any absolute values on this whatsoever. The negatives take care of themselves because if one factor is negative, then the other one has to be as well. All right, try this one. We got just 2 more here. See if you can figure out what this radical would simplify to. All right, so if we just simplify, we're looking at removing groups of 2, whatever the index is. So how many groups of 2 can we remove from the x's? We have 5 total, so we can remove 2 groups of 2 with how many remaining? 1 remains inside. So again, the remaining and the groups are the powers, right? So we remove an x squared, and we have an x to the first left inside the radical. How many groups of 2 can we remove from the y's? 1. And that leaves how many y's inside? Still leaves 1 inside. So here's our simplified form. Okay, now let's check and see if we need to worry about absolute values or negatives. So can x even be a negative value here? If x is negative and taken to an odd power, the product's negative. So in order for that to be a non-negative inside our radical, what do you know about y? It would also have to be negative. So those are dependent on one another. They're either both positive or both negative. So if we look at the situation where x is negative, we know that y also is going to be negative. So let's evaluate this. Okay? Inside the radicals, if x is negative and y is negative, do we need to worry about any absolute values here? No, the sign will take care of itself. What about on the outside with the x? If x is a negative and we square it, what do we get? Positive. So we don't even need to worry about the x, but what about the y? If y is a negative, would this whole simplified form guaranteed to be negative or positive or non-negative? No. So you do need the absolute values, but only around the y. All right, here's the last one. Okay, try this one on your own for me, please. All right, if we simplify here, we're looking at whatever our index is, groups of index of 2. So how many groups of 2 can we remove from the x's? Just one group. Are there any x's left inside the radical? No. Move to the y's. How many groups of 2 can we remove from the y's? 1, which leaves how many y's? 1 inside. So here's our simplified form. Now we need to go in and figure out, do we need any absolute value symbols? Okay, so let's test x. If x is negative and we square it, we get a positive inside. So is x going to be dependent on y or completely independent from it? It's independent, right? X can be positive or negative regardless of what y is. So we need to test that first. So without considering what y is, if we have a negative x and we reduce it to this simplified form, are we guaranteed to have a non-negative value? No. So what do we need around the x? Absolute values. Okay, so we can go back in now, disregard that. We've already accounted for the x's. Let's test the y. Can y be a negative value? If you take a negative and you cube it, your overall sign is negative times a positive here. So what do you know about y? It can't even be negative, right? You know that there's a restriction on y. So is that restriction shown in our simplified form? Yeah. So you don't even need to consider that y could be negative because it can't. And you see that in the simplified form. You see it in the original form. So that's the only absolute value you need is around the factor x.